Hello, good afternoon, everyone. This is Kanu Bhutani here, and today we are going to speak on two very important topics that we have in ML and while working in AI and machine learning. They are false positive and false negative, and how to deal with it and what they are. So we will see all of them. So the very first thing we will see that what is false positive. So it is the okay, let's read this. Incorrectly identifies something as present when it is absent. So it is saying by mistake it is saying yes it is there, but that is not there. Where it occurs in medical tests, security scans, spam filters, and machine learning. When it happens, it happens during data analysis, testing, or automated detection processes. And who it affects testers, analysts, doctors, engineers, and decision-making professionals. Why? Due to the noise, imperfect modeling, and overlapping feature characteristics. So if it is like even in machine learning, we know that there is uh, more of learning. Imperfect models are there in machine learning. When you have to make it learn normally, it learns more, then it gives the false positive. Say, for example, if you're writing 7, 7, 7, but sometimes it will understand 7 as 4 because of over learning. So, over learning should also not be there. So, it identifies as present when it is absent. So, 4 is absent, but it identifies as 4 when we write 7. So, that is wrong, which the common in disease diagnosis, fraud detection, and quality control scenarios. And how it is caused by algorithm sensitivity, data errors, or biased sampling processes. Now, the totally opposite on that is false negative. So, what is false negative? Fails to identify something present, wrongly marking it absent. Here, this is totally different. It fails that it is present and it wrongly marks it as absent. So, even if it is taking as 9, 9 and 0, 0, 0, but 0 it is showing as 9 and it is failing to identify the present of 0 where it is wrongly identifying something which is wrong. Say, for example, if the person is having um, a person who says, I need a credit card, but he is wrongly marked as he doesn't needs the credit card. So it will be a loss to a company if we even lose one person who needs a credit card and he says that no, he doesn't needs a credit card. So that is false negative, that is to be protected. Where it is found in security checks, medical screening, fraud systems, safety testing. When it happens when the detection thresholds miss actual cases or events. So even in machine learning, we have less learning. When it is less learning, how much it should be learned, it is less learning, so the false positive negative comes up. Who is impacted? Security officers, medical staff, analysts, and affected end users. Why it is caused by low sensitivity, incomplete data, less learning, weak detection algorithms, which common in cancer tests, intrusion detection, and credit fraud screening. And how it is done? it is the results of underfitting models, as I told you, poor training data, or weak parameters. So we have to take care of false positives also and false negatives also. I hope this session would have been very informative to you. We will see another important topic in next session. Thank you very much. Bye.